In this video, we're going to dive into a problem involving the magnetic force on a moving charged particle. Imagine we've got a proton. The proton is a tiny positively charged subatomic particle found right in the nucleus of an atom. Our proton is zooming through a magnetic field of 0.85 Tesla that is perfectly perpendicular to its path. To visualize this, let's say the proton is moving toward the right in our drawing, while the magnetic field points straight up. This interaction gives our proton an acceleration of 3.5 times 10 to the power of 4 meters per second squared. So the first thing we need to find is how much magnetic force is actually acting on this proton. To figure this out, we just need to apply the Newton's second law. You probably remember that famous formula, F equals the mass multiplied by the acceleration. Since we know the proton's mass is 1.67 times 10 to the power of negative 27 kilograms, and its acceleration is 3.5 times 10 to the power of 4 meters per square second, we just multiply them together, and this gives us a force of 5.85 times 10 to the power of negative 23 Newton. To figure out the direction of this magnetic force, we can use the right-hand rule. Here's how you do it. Point your fingers straight up in the direction of the magnetic field, and then point your thumb to the right, following the velocity of the proton. In this position, your palm is facing directly towards you or out of the screen. Since our proton is positively charged, the force follows the palm and points straight out of the screen. Just a heads up, if we were dealing with a negatively charged particle like an electron, the force would point in the opposite direction, which is right into the screen. Okay? Next, let's figure out how fast this proton was moving, or the speed of the proton. Since we've already calculated the magnetic force and we know the quantity of the charge and the field strength, the best tool for linking all these parameters to find the velocity is the magnetic force formula, which is F equals the value of the charge Q multiplied by the velocity multiplied by the field stress B, and then multiplied sine theta. Here, theta represents the angle between the velocity V and the magnetic field B. This problem specifies that the field is perpendicular to the velocity, so the angle theta is 90 degrees. Sine 90 degrees is exactly 1. Then this equation simplifies nicely to F equals QVB. We can just rearrange this formula to solve for V, which gives us V equals F divided by Q and B. If we plug in the force we just calculated, which is 5.85 times 10 to the power of negative 23 newtons, along with the proton's charge of 1.6 times 10 to the power of negative 19 coulombs, and the magnetic field, which is 0.85 Tesla, we find that the proton is traveling at a speed about 4.3 times 10 to the power of negative 4 meters per second.